So we get our panel back. We'll go ahead and get started. So I hope everybody had a good lunch and enough coffee so they can stay awake this afternoon. So next, the first talk this afternoon is going to be a presentation on public water agency perspectives, and that's going to be led by Chuck Hanson. And Chuck, I'll let you introduce the rest of your group there.
Thanks, Sam. My name is Chuck Hanson. I'm a fisheries biologist, and with me on the panel today are Paul Hutton, who is dealing with issues of hydrology and hydrodynamics, Dave Fullerton, who is dealing with issues of sampling design and data analysis of existing data sets, and Francis Brewster, who deals with water quality and lower trophic levels. And we're here as a panel to describe and discuss the Public Water Agency's perspective on the delta interior flows and the related stressors. I'm not going to spend much time on this. You've heard a lot of discussion over the past 2 days about the importance of the highly altered environment that we're dealing with. We've had over time losses in tidal marsh habitat. We've had increases in reservoir storage and upstream impoundments, changes in agricultural irrigation and agricultural practices within the Central Valley, changes in exports as well as upstream demands. We've had some discussion about changes in sedimentation, sediment dynamics. There have been changes in channel configuration, both in the form of dredging and making channels deeper for commercial navigation, as well as the riprapping that's been discussed. One aspect that hasn't been touched on, and I just want to bring to your attention, we focused really over the past couple of days on the state and federal water project operations. And I'd like you to be aware this is a map that's taken from the DWR Delta Atlas and represents the results of an inventory that was done a few years ago by the California Department of Fish and Game at the time. And they identified over 1,800 diversions that are located within the delta. Many of these are small. They're unscreened in most cases. They provide irrigation water primarily for local agricultural practices. But because of the synchrony, a lot of these diversions are operating during that spring-summer period of irrigation, coincident with the period when many of the native delta fish are inhabiting the system, either for rearing habitat or as a migratory pathway. These have an effect on local hydrodynamics, interior delta flows, and other aspects that are related to the subjects we're talking about. One of the additional aspects I'd like to at least bring to your attention is an effort that Paul Hutton has underway as part of a larger collaboration with other investigators. The effort is developed to investigate and develop a hydrologic simulation model for historic flow conditions that occurred within the Central Valley and the Delta. The purpose of the exercise is to better understand the relationship between what we call unimpaired flow, natural flows that were occurring. This is the unimpaired flow estimate from this preliminary example. These are estimates of natural flow from the earlier preliminary analysis and compared to the existing current flow conditions. And by better understanding through the simulation and hydrology how these flows have changed, it helps provide guidance on restoration strategies that deal not only with seasonality and the magnitude of flows at various locations, but also the flow habitat interactions that John talked about that we think are so important in terms of the ecological functions that flow supports, as well as the habitat conditions that occur within the delta. And I'm not going to go through this in detail, but you've seen pictures over the past couple of days of the highly altered delta ecosystem, the trapezoidal riprap line channels that now serve as habitat for migrating salmonids, as rearing habitat for smelt and other species. And you've heard John talk this morning about the interaction between the flows and the habitat conditions and how these highly altered conditions with the riprap levees have changed that interaction and those ecological functions. And it's our feeling that simply providing more flow in the absence without also addressing the habitat issues is not going to be an effective way in the long term to reestablish these ecological functions. And one of the pieces of information that I point you to in that regard is the result of the salmon survival study that Pat Brandis presented yesterday. Pat presented results from a 2011 acoustic tag study that was conducted on the San Joaquin River. And 2011 was an important year in California because it was a really wet year. We had a lot of water coming through the system and had high flow conditions. And yet the results of the acoustic tagging study showed that salmon survival was about 2%, as low as it is under low flow conditions. It didn't respond to the higher flows in these channels as we would have predicted based on our earlier flow survival relationships. And that suggests that there are fundamental changes other than changes in flow that are also affecting the survival of these fish as they're migrating through the system. A question came from the panel yesterday that in essence said, what's changed so dramatically in the last decade that would affect this survival relationship? And we've heard a number of presenters over the past 2 days talk about what changes have occurred in the last decade or two in the Delta. We've heard about changes over time in trophic conditions, introductions of a variety of non-native species. We heard earlier this morning about SAV colonization in the South Delta and many of these channels. We've heard about increasing clarity of the water and reductions in turbidity over time. Many of these have occurred in the last 10 or 15 years. One topic that hasn't been discussed is the change in the predator community that's now inhabiting these channels, these areas of the South Delta. And there's an interaction between the predation risk and the flow and channel geomorphology. And anecdotally, the Department of Fish and Game and UC Davis have been doing electrofishing surveys for about the last 15 years. And what those electrofishing surveys have shown is a dramatic increase in the abundance and the change in the species composition towards, in many cases, non-native predatory fish inhabiting these reaches of the Delta. Historically, we had striped bass as our primary apex predator. Now we have a substantial population of smallmouth bass, of largemouth bass, and of other predatory fish. 15 years ago or so, virtually no one was fishing the Delta for largemouth bass. Today it's a world-class fishery with nationally televised tournaments. We have tournaments for largemouth bass virtually every weekend on the Delta now, and fish that are in the 10 to 15 pound range. So there has been a fundamental shift. And the results of many of our acoustic tag studies are starting to also show evidence of high predation rates, these localized predation hotspots that we think are important in terms of the overall survival and how these juvenile salmonids and other fish are responding to changes in flow as well as changes in habitat conditions within the Delta system. We've had a variety of discussions, and Pat Brandis talked a lot about it, and Bruce spent some time on it, of the VAMP program, and to a lesser extent, the 6-year steelhead survival studies that have been carried out in the past or are currently being carried out in the San Joaquin River. Those studies, historically relying on coated wire tag mark recapture techniques and more recently on acoustic tag techniques, have provided us a lot of information about how juvenile salmonids, both salmon and steelhead, respond to hydrologic conditions, flow junctions, and other factors in the South Delta. They're also providing us this kind of information on route selection, on reach-specific survival rates, and how the fish are responding to their environment. So we're learning a lot from those studies, but they're still inconclusive on many aspects. And they're encouraging. We support the continuation of those studies. And in fact, in some cases, much the way David talked about this morning, we can start to use acoustic tagging in combination with the kind of adaptive management that Bruce described to actually manage OMR, for example, at different levels, or to experimentally test how these fish are responding to those kind of conditions occurring in the central and interior delta as they migrate down from the San Joaquin River system. We also heard yesterday a lot of discussion from Russ Perry and John Bureau about their studies on the Sacramento River side. And the importance of these, not only are they shedding important light on how fish are moving through the Sacramento River side, the importance of these flow junctions and moving from the Sacramento into the interior delta, and how that process affects their risk of mortality, their survival rates, the rate of migration through the entire delta system. But importantly, from at least our perspective, they demonstrate the extreme power if we start to better integrate the fishery studies using, say, acoustic tagging technology with the measurements and the simulation modeling that John talked about, that give us the coupling then of in space and time, here's how the fish responded, and here are the attributes of the physical conditions, the flow vectors, the velocities, those conditions that the fish are responding to. And we think it's important to continue and to push on the interdisciplinary nature of the studies that are just starting to really emerge, and to use that as a platform for moving forward as we start to investigate some of these other processes. And the results of those studies to date have shed a lot of light that we're using to help better manage various aspects of the system. The top graph is a graph that shows the National Marine Fisheries Service established 1% incidental take level. This is for spring run Chinook. And for spring run, we use a coated wire tag surrogate mark recapture study to actually develop estimates for what the take is expected to be. And that's why you have multiple bars for a given year, is that there were multiple releases. But what this shows is that for this period, starting in 2006 and continuing through 2013, we've been consistently below this 1% incidental take level. Similarly, for winter run Chinook on the bottom graph, the incidental take is established by NIMS at 2%, and this is based on using, in this case, starting in 2002, carcass surveys in the upper Sacramento River to estimate adult escapement. And from those carcass surveys, they generate what's referred to as the JPE, the juvenile production estimate. And then based on the numbers of winter run sized fish that show up in the salvage and the corresponding JPE, they can calculate this percentage of incidental take. And we think this is an important process from a couple of perspectives. One is that these incidental take levels vary in response to changes in abundance. And we think that's an important process reflecting changes in escapement, overall abundance, and the numbers of fish that are in the system. The second is that I think these results and the consistencies of these results over time demonstrate that we're starting to better understand the environmental cues, the geographic and temporal distribution of these species in the delta, how changes in operation can affect their risk of salvage and take at the pumps. And I think the fact that these have been consistently operated over a period of time suggests that the existing management structure and strategies are working. They've been effective in providing protection from incidental take during this most recent period when these kind of actions are in place.
Chuck, can I ask a quick question?
Sure, Steve.
Those are for Sacramento salmon?
These are for Sacramento River spring run on the top. And Sacramento
so
River,
no San Joaquin in there.
There are no San Joaquin River Chinook that are currently listed under the ESA. The only salmonid listed under the ESA on the San Joaquin River side currently are steelhead. These are normalized graphs for delta smelt in the blue and longfin smelt in the red. The green bar shows the incidental take level in the existing biological opinion. And from these, you can see a couple of things. One is that in these recent years, the take of both longfin and delta smelt has been below the threshold established by the incidental take permit limits. We can also see that historically we had occasions where there was substantially higher take of both, well, in this case of delta smelt. And some of the presentations that have been presented earlier use some of that earlier data as part of their analysis of the effects of water project operations on delta smelt, for example. And we think that's useful and informative, but it's also important to recognize that the data and the way the projects were operated back in the 1980s, the 1990s, and the early 2000s is not representative of how the projects are operating currently. And I'm going to talk a little bit, as did other speakers, about the importance of looking at turbidity and OMR as management techniques that are currently being employed to help avoid some of the take issues. I want to present this just by way of example. And this is an example of what I consider to be a healthy scientific debate. We had a paper that Wim Kimmer presented in 2008 that tried to assess and evaluate the effects of water project operation on delta smelt salvage and take. And Wim was very forthright. He said, hey, I've got large confidence limits. I haven't been able to find an effect in the subsequent fall midwater trawl data. But B.J. Miller took challenge with a number of the assumptions and the relationships that Wim had used in his original analysis. And that led to a pretty open debate within the scientific community about how we can start to structure these sorts of analyses. And I think it was painful at the time, but I think it advanced the science. And I think we're better off today for having gone through that exercise. And some of the reason I say that is that analyses that have been done more recently, some of the work by B.J. Miller, the Thompson and McNally kinds of work, are much more sophisticated statistical analyses and approaches of how to actually use multivariate data in these kinds of biological issues. The other thing that is emerging, and we've got a delta smelt life cycle model that Monder and DeRiso put forward. Kenny Rose has a delta smelt life cycle model. So they're starting to apply a lot of what we're learning to these other techniques for data analysis, for organization, and for looking at these effects of not only entrainment and water project operations, but food supply and a whole variety of other important covariates. In this particular example, most of these analyses identified water project entrainment effects, but they identified them really as weak covariates in the overall analysis, not negligible, but simply weak in the overall analysis of various factors. A question came up yesterday as well about sampling. Virtually all of the analyses that we're talking about all start with some fundamental understanding of what are the abundance trends and how do they change from one year to the next for our target species like delta smelt. Our sampling program was largely developed to sample striped bass back in the 60s. And historically, we have relied on the fall midwater trawl as our primary sampling method for purposes of developing indices of abundance from one year to the next. And they have largely driven many of the analyses. More recently, the Department of Fish and Wildlife, the U.S. Fish and Wildlife Service, and others have started to investigate how accurate and effective those sampling techniques really are. This top set of data show a comparative analysis where they went side by side with the Chips Island midwater trawl, the fall midwater trawl, the spring Kodiak, and the summer tonet surveys, and sampled delta smelt. And what we found was that there was an order of magnitude or more delta smelt collected by the Kodiak trawl than these other techniques, which suggests that some of the other techniques, like the fall midwater trawl that we've relied on so extensively, may not be as robust as we originally had hoped in terms of providing reliable information on the changes that have occurred from one year to the next in population abundance trends of delta smelt. In the right-hand panel, we've plotted data from the base study on longfin smelt and the distribution of pre-spawning adults. And superimposed on that in the blue, we've plotted the geographic area that is sampled by the Fall Midwater Trawl Survey. Again, historically, we've largely used the midwater trawl as our primary method for indexing abundance. But as you can see by this, it's missing a substantial portion of the potential pre-spawning longfin smelt population. And so we're starting to explore other sampling techniques, like using the base study midwater trawl data or the base study otter trawl data that has a broader geographic coverage for this species that is geographically dispersed not only within the Delta, but within other parts of the San Francisco Bay system. In the bottom panel is an example of how we're starting to look at the effects of things like turbidity on the efficiency of the nets, the catch probability. We're doing additional analyses to compare day versus night collections to see how that affects it. Different gear types like the otter trawl versus the midwater trawl. The department currently has a program to investigate size-specific collection efficiency based on the mesh of the nets that are being used to try and understand better how changes are occurring in terms of the selectivity of these various gear types, because that's really a fundamental component of our overall monitoring and analysis program. This is a figure that Matt Nobriga showed yesterday. And I want to present it for two reasons. One is I want to present it as an area of agreement, that there has been a tremendous amount of analysis on salvage, OMR, and turbidity relationships for delta smelt. And what this shows in the red are occasions where no delta smelt were salvaged, and the blue dots are periods when delta smelt were salvaged. And what you can see for management purposes is that this quadrant, turbidities of about 12 NTU or less, OMR flows of about minus 5,000 or less, represent an area where we don't collect very many delta smelt in the salvage operation. As turbidity starts to increase, and certainly as OMR starts to become more negative than minus 5,000, we start to see evidence of higher salvage. And that provides us then with a management strategy that is gaining momentum that allows us to better manage how we operate the system collectively, how we use the data on the geographic distribution and the presence of these sensitive species in combination with water quality and operations to help address some of our take management issues. This is an example of an analysis that Rick DeRiso did back in 2010. Kenny referred to it yesterday. This is the relationship between the normalized index of abundance for both winter run and spring run Chinook in the December through March period versus OMR. And we had a presentation by NIMS yesterday where they had done similar analyses but on a daily time step. Greg, a few minutes ago, talked about the importance of looking at various time intervals as we start to reanalyze this data. And we think that's appropriate to start using these kinds of techniques collectively and collaboratively to evaluate the relationships between OMR and salvage for these species and what are the factors that affect their risk of salvage mortality at the South Delta. Similarly, I think this gives it a good example for the kinds of studies that David talked about in terms of the 2012 stipulation, where we can then start to experimentally manipulate OMR as we have acoustically tagged juvenile Chinook salmon or steelhead migrating through the system and responding to various kinds of interior delta flow conditions. So we have both an analytical opportunity as well as a field experimental opportunity to further investigate and evaluate these kinds of relationships. One last thing I'd like to touch on before moving on, and that's the whole issue of prescreen losses within Clifton Court forebay. There was mention yesterday about the importance of prescreen losses. We think they're largely attributable to predation within the forebay. There have been a number of studies conducted to date on juvenile Chinook salmon and steelhead, and those studies are convincing in the sense that they all, in essence, point to a similar kind of an answer. And that gives us confidence that we've got at least an understanding of what's happening with the salmonids. And that understanding has actually materialized into management changes and changes to the forebay that are currently underway to help address the prescreen loss predation issue. This is the one study that we have on Delta smelt, and it was done by Gonzalo Castillo. And here he used Delta smelt that were cultured from the UC Davis culture facility. They were released into the forebay and then subsequent recaptures. And we agree with the fundamental approach that was used. But in this example, you can see he did his releases in relatively late period in June. It's a period when water temperatures are starting to become stressful and approaching lethal levels. The second is that the export rate from the SWP during this study was extremely low. It was only a couple hundred CFS. And so we don't think this represents a representative kind of a condition in the fall or in the spring and under typical export conditions for use of this test. And we're not saying that the test isn't useful. What we're saying is that we think more of this kind of testing needs to occur over a wider range of environmental conditions to better represent what prescreen losses are, so we have a better foundation for evaluating this as an effect and making better management decisions about how to move forward. And we'd like to be collaboratively involved in helping to design and implement those kind of studies because we think they are important. So there I focused mostly on the entrainment and impingement and salvage issues. I'd like to make a transition quickly to other stressors. And this has to do mostly with water quality. We've heard earlier today about the proliferation of submerged aquatic vegetation in various channels of the delta, as well as, in this case, water hyacinth. We don't see evidence that that spread of SAV is attributable to SWP or CVP operations, but we have emerging science that says this nutrient concentration, the nitrogen to phosphorus ratios, may be extremely important in terms of how some of these various SAV species, like Ajuria densa, respond and proliferate in the delta. And we think it's important to better understand those relationships, both from an experimental standpoint as well as from the standpoint of what kinds of management actions might be most appropriate for dealing with those. We have a similar circumstance with Microcystis. There's no evidence that SWP or CVP operations have increased the spread of Microcystis, but there is some growing evidence that ammonia loading is a factor that's contributing nitrogen that may be accelerating the growth of Microcystis in some areas of the delta. And it's not surprising that as the public water agencies, we generally support source control as opposed to dilution for dealing with this kind of issue. But we need better understanding of this whole dynamic in order to better articulate our concerns as well as to better identify solutions or management actions that would fit into this. This is another example, and we haven't talked about contaminants, and I'm not going to spend much time on it, but the whole issue of stormwater runoff and the issue of point and non-point source pollutants is another concern in terms of other stressors in the delta as it relates to flows and habitat quality and the response of the fish species. And we think that there is an important role for looking at these kinds of relationships. And the last one I want to touch on is the whole issue of nutrients, phytoplankton and zooplankton production in the interior delta, how that relates to factors like residence time, interior delta flows, how productivity changes in response to those kind of conditions, as well as how that productivity from the interior of the delta can be exported down to Suisun Bay and other places to be made more available for use as a food supply for many of our native fish. And so we're extremely supportive of the idea that we need to better understand these trophic interactions and how the nutrients, how the production, how residence time and other factors influence these dynamics within the interior delta. And as John pointed out and other presenters have also pointed out, we also need to better understand how the role of wetland, tidally influenced wetland restoration or floodplain restoration in various portions of the delta and the tributary rivers can also affect production of food supply that we think is so important in terms of supporting the pelagic fish species as well as other fish inhabiting the estuary. And with that, I have just 4 kind of summary conclusions. One is that we think there's a need to identify the functions of these interior delta flows under pre-development conditions and to help use that information to guide and identify how we might recreate some of those functions within the altered context of the habitat conditions we currently have. Paul's work and others are going to fit into that component. We also think it's important to identify what can be achievable and to identify opportunities for habitat restoration to benefit native species and to provide that habitat flow interaction that John talked about. We think it's important to gain new insights into how flows affect fish distribution, as well as the various natural processes that are occurring in the interior delta, and how we don't see that there's a need currently for additional regulation of flow alone to provide measurable improvements in species health, but we do see that there's an important element here of providing a stronger linkage as we move forward between identifying solutions that address flow as well as habitat in the context of ecological functions within the interior delta. And we think programs like BDCP and others that bring both the hydraulics as well as the habitat components to the table are an important tool in terms of how we address this fundamental issue. And with that, I think we'll be available for questions.
I think we're running a little bit behind. Good time for one quick question.
I'm just curious about something. You had the slide with the delta smelt entrainment showing it being under the 1% take limit. I'm just curious, aren't some of those years that were successful, weren't those years that there were court cases involved with the standards that actually imposed? I mean, that's the result of the flow standards that were in place at the time, right?
Correct.
So they include policies that state water contractors, federal water contractors did not feel were appropriate.
In some cases, Steve, absolutely.
Okay.
I have a follow-up question on that analysis. I guess I don't understand what take is. Is take equal? I mean, you said it was equal to salvage.
Take is, for a species like delta smelt, it's a very sensitive species. It doesn't respond well to handling. And so, in that case, take and salvage are basically synonymous because we think that the vast majority of those delta smelt that do end up in the salvage operation don't survive that process.
So it doesn't include anything that happened before salvage?
It does not include. We have prescreen losses, but take does not account for prescreen losses, okay. Nor does take account for fish smaller than 20 millimeters.
Okay, thank you.
Okay, I think we're going to go ahead and move on. Next speaker is Don Weston. He's going to talk about pesticides in and around the Delta.
So we'll have a chance to...
Yeah, they'll be around later on. So.